Welcome back to Unit 3, Lesson 3, Part 3 of the video. This part is optional unless you've missed class. Okay, so we left off with the parts that were necessary to indicate when and where to start and stop copying a gene. Now we're going to actually look at the actual process of transcription. So first of all, just so we don't lose sight of the fact, we are going from DNA to mRNA with the whole purpose of making a working copy of the gene to protect the DNA. So we want to protect the DNA. This process has to occur in the nucleus. And we are going to divide our page into roughly four equal quarters. Okay. And last day, when we were discussing replication, there were 4 key enzymes. Today you'll be happy to know you only need to learn about one key enzyme. It's not that there aren't other enzymes involved, it's actually because this process is so complicated that when we teach it at the grade 12 level, we kind of make out one enzyme to be the superhero, RNA polymerase, and we act like it does all of it. And it's not that it does all of it, it has lots of helpers that help it out, but it simply has other sort of, you can't. Okay, so last day when we were talking about DNA, there were 4 key enzymes involved. You'll be glad to know today there's really only going to be one key player. It's RNA polymerase. While there's lots of other enzymes involved, without RNA polymerase, this process doesn't occur at all, and it's so complicated that we simplify it for the grade 12 level. Okay? So in the first picture, we're going to look at our template DNA. And last time, when we drew our template DNA, this was what meant to represent an entire chromosome. But today, it's only going to represent a small section, a particular gene. And we're going to start with, we must have, and we'll just stay on the same strand, make sure you don't go switching strands. We must have a promoter. Okay, and this is actually going to be at the 3' end of the strand. Okay, a little further down, we'll have the initiator, the start site. So initiator or initiation site. And then quite a ways down, follow the same strand, make sure you're not switching strands. You're going to have the termination site. And this is going to represent your template DNA strand. And it's not called the parent strand because we're not going to get 2 new strands out of this. It's a template. We're only copying one side. And we are going to actually complement one side to get our single-stranded mRNA. And just to recall, if that was your 3' end up at the top, then the termination site is going to be down at the 5' end. So in the first stage, we want to get the party started. So in the first stage, the promoter recruits transcription factors. Transcription factors are like key players that, if they're there, will then recruit RNA pol. So they're kind of out there waving, holding a sign, says party this way. They're promoting the gene. They're saying, this is a great gene to copy. Come on in, RNA Paul. Do your job. So in comes RNA polymerase. Thanks to your transcription factors, which are abbreviated TFs. So step 1, transcription factors. And each gene has its own unique set of transcription factors that can recruit RNA Paul. In fact, many cancers are caused by transcription factors recruiting RNA Paul at the wrong time and turning on the wrong genes. So they recruit RNA polymerase, which you've probably noticed I'm shortening as RNA Paul, to the promoter site. Okay. Once RNA polymerase is there, it starts to work. And what it does is basically all of those things that RNA Paul did, or sorry, DNA Paul did, helicase did, topoisomerase, ligase, all of those jobs, RNA Paul takes on as far as we're concerned. So if we started out, this was the promoter, and this was the initiation site. Remember, this is going to be 3'. And down here we had a termination site. And the template strand was, sorry, there's a mistake there. This is DNA, so the template strand was TACG. When RNA Paul got going, it would unwind it, unzip it, and start pairing it. And it would work building the new strand in the 5' to 3' direction. The T would pair with an A would pair with, because it's building mRNA, a U. That's one of the differences between RNA Paul and DNA Paul. It'll only pair A's with U's. A C with a G, and a G with a C to start building the mRNA. Okay. So just to go over what happened. So step 2, RNA Paul unwinds. That was like topoisomerase in replication. So it unwinds the DNA. Then it unzips the DNA like helicase did in replication. And then builds mRNA strand based on complementary pairing with the template DNA. And it continues on until it reaches the termination site. doing replication, it unwound it all the way, and it ended up looking like what we call a fork, a replication fork. Here, it only unwinds the little section that represents that gene, not the entire chromosome. So instead of having this open fork structure, we have what's called this whole sort of shape here is called a transcription bubble. Okay. And then we go on to our last picture, where once the RNA polymerase hits the termination site, it actually falls off the DNA. And the DNA goes back to being its normal double helix self. So we get our template DNA. Sorry, guys. We get our new copy of mRNA, which is this nice linear strand of mRNA. Plus, we get our RNA pol back. So it can go on to more parties and copy and make more mRNA. Nothing's damaged the promoter site. It's still there on the template DNA. The initiation site's still there. For those of you with a cartoon mind, I kind of think of these sites like in a Roadrunner cartoon, holding up their little signs, party here, start here, stop here. Think of Wile E. Coyote holding up his signs. This is, sorry about that, I just keep hitting the key with my arm. So termination site. So now this DNA can be reused as a template to make more copies of the same mRNA or to make copies of different genes along its length. Now mRNA, next job is to go out to the nucleus, or sorry, out of the nucleus to the cytosol to do its job. So the mRNA will be processed, then exit nucleus to cytosol to do its job. And we're just going to finish this little video clip up here. If you have any questions about that, you can come see me, ask me in class. We are going to continue on to part 4 of the video, so if you miss class, you should go see that. Have a good day.